Alright, we're live. Awesome. So, yeah, finally wrapping up the sprint for this week. Signed into my account and everything, so I'm all set up here. I did close this issue. I know that it did also say see if React can or should be used for displaying download link. I've decided that this is not the UX I want. This is how other randomizers do it. But I think that it would be probably better if you just had like a single click to download everything. What I'm thinking is we could just have like a checkbox or something that you could click to decide whether or not you want to download the spoiler log as well. So you don't need to go to a different page or anything to download stuff. You can just click on the generate ROM or like generate randomized ROM button or whatever, and after you click that, that'll be like the submit button, and it'll just give you the download immediately. That seems like it'll be pretty simple to do. I don't think we need to do this like redirect to another page. And also, I did poke around a little bit, and there is a redirect in Rocket as well. So there's no need to even do anything special in React. So I think we're good there. I also spent a little bit of time on my own just looking at pure script stuff. So there's Thermite, which seems like a pretty decent framework. It's like a thin wrapper around PureScript's React bindings. So I don't really need to do anything fancy. I just need to use this framework if I want to use PureScript. Looks pretty easy to use. I'm not sure how exactly it works just yet, but it looks fairly simple. So I might dedicate maybe like one task to this next sprint, just a spike to look into this Thermite stuff. But yeah, ultimately I don't think we're going to do too much with the UI initially. We're going to probably do something very simple, but you know, it'd be cool to have like a little PureScript project as well. So I think I'll use Thermite. I looked into Idris a bit more. I don't think it's at a point where it can be used for building like a React app or anything like that. So I'm just gonna leave that for now. I think PureScript is probably a decent option already as it is. And yeah, I mean there are also like Rust frameworks for this stuff too. Like there's U, I think, and I can't remember the other ones. I know there are others out there, but I didn't really look into them. So I'm going to just say, well, we'll just stick with the plan and see where things go. I mean, this might be a mistake. This might not be a mistake. Ultimately, I don't think it's going to make a huge difference. I mean, some people might complain because their favorite pet technology isn't being used, and you know, I get that. Everybody has their favorite pet language, pet whatever for a lot of situations, but you know, when it comes to like building web apps, there's so many different options. Many of them are equally viable with different trade-offs, and you're just going to pick the language and you know, frameworks and tools that fit your I guess ideologies best. Whatever you believe in, whatever you like best, right? So that's just how it is. Probably not a big deal at the end of the day. I also moved the functional spec to a Google Doc, so now it's backed up on the cloud. I don't have to worry about losing this thing again. Yeah, not too much has changed here. I added like a one-hit KO mode. I added some more dependencies like anyhow and rand, because these are basically these are kind of a given considering we're building an app in Rust, and you know, applications have to do error reporting, so anyhow has to happen. Randomizers always have to use random numbers, so we're probably going to have to use some kind of RNG crate, and rand is like the popular one that most people use. So yeah, I'm just gonna stick with that. Here's our diagram, the simplified one from last time. So there were a couple of adjustments. Apparently these are unidirectional arrows in the original diagram I made. Ultimately, probably not going to matter too much, but yeah, this is I think this is looking pretty good. Yeah, kind of sparse Definitely could be fleshed out a bit more if we're trying to do something a little bit more formal, but I think this is fine as it is right now. So today the plan is to try and finish off our tasks for the sprint, which is just laying out the interfaces for the project. I definitely feel like I could have done more this sprint if I really pushed myself to. May try and take on more next sprint. We'll see. But yeah, this was like a combined total of I think 3 and 2 story points. So I mean, we still got we're still hitting our quota if we finish today. So yeah, let's just dive right into things. I think right now what I have open is that thing. Oh right. One more thing I should mention is I have the randomizer code now here. So this is from a prototype I made before. It's a little bit small. That's fine. We're not going to be staring at this too much. Well, actually, maybe we will be. Let's blow this up a bit. Zoom in. I think that's good enough. I just shrink this and move this out of the way in case there's chat. Alright, so what I'm going to do is take this old prototype that I did, and I'm going to be designing the interfaces based on the methods and functions that we're calling, so that way we have a pretty good idea of what our interfaces need to have available. So this is a good strategy for building projects out like this, is to do some prototyping. There's a saying, always build your applications top down, except for the first time. And yeah, basically I built this thing bottom up, right? I just implemented things. Everything is there's no abstraction boundaries here. We just wanted to see this whole thing working without making it like too testable or giving it the ability to like swap out certain components, and this way we can test that this thing works end to end. And we also have a fair amount of confidence that the interfaces that we design will be pretty decent, at least. Like, though, if they match what we're doing here, then we should be able to, you know, implement things, or we should be able to design our application top down and not have any issues later on. So this is a generally good strategy to go about designing applications, and that's what I'm going to be doing today. So because I already have a nice randomizer prototype, we're going to start by designing the ROM writer interface. I think that's a good idea. So I have this create randomized ROM method here, or I shouldn't say method, this is just a standalone function. I don't know, function, method, kind of similar. Method more of an object-oriented terminology, but whatever. So create randomized ROM takes a file path. It also takes a seed. So here I was using unsigned 64-bit integers as seeds. Don't know if that's really necessary. I mean, that's a pretty large seed, so we might change that. This might be its own interface method, or we might take parts of this and turn those into interface methods. Let's read this a little bit more. So that's actually what main calls. So main just calls create randomized ROM. It gives a JSON file. So this is actually, this file path is not the file path to the ROM. So that's a little bit confusing. This is actually a file path to the master copy of the JSON. Actually, this is a master copy. And yeah, it passes in a seed of 0. Obviously, real seeds are probably not going to be passed in, you know, just as like numbers like this. Actually, maybe they will be. I don't know. I'll have to take a look at some of the other randomizers out there and see what they're doing. But generally, yeah, it doesn't. I don't think it's going to matter too much. It's just that this is kind of a large number, or it could potentially be a very large number. So like entering a seed in manually might take a long time unless you know, are just copying and pasting. Let JSON data equal this. So we have a JSON module that loads the configuration, or at least it loads the doors. That's part of the configuration stuff. At least I'm going to consider that part of the configuration stuff. Here we're using our random library to call the RNG. That could actually be abstracted away. So we could actually add an interface to hide the RNG behind, because we actually might want to swap out RNG implementations. There's a potential that the RNG implementation is bad. For whatever reason, maybe there's like a bug that's found in the future and we want to swap it out for a different one, or a different library that might be faster or better, or maybe people ditch rand and decide, here's a better standardized RNG library to use. I think that might be a good thing to abstract out. So let's, I want to add that to the diagram actually. So let me do that. Move this in a bit. We'll just add another bidirectional arrow here from the Rocket API. So main and this method here are probably going to be our Rocket API. Wait, what? Sorry, I got like mixed up in my thoughts. Like the Rocket API kind of corresponds to main in the code that we're seeing. We'll put the randomizer here. Okay, you can go there. Or what's this? What is this line? What? Eh? Can I delete that? Okay, yeah, that was weird. I'll put that there. We'll call this RNG. Yeah, so this is our RNG interface. That seems pretty decent. We might actually want the RNG interface to be called by the randomizer itself, but let's see how this is being used. So this creates an RNG. That gets passed into the randomizer logic. So we might actually want to move that around. But yeah, we'll see. Or maybe this will also have an arrow to the RNG. That might make more sense. So like move this in between here and have them both share the RNG. It's possible. I mean, generally, this is going to create the RNG and then it's going to pass it into the randomizer and then do stuff there. Or we could have the randomizer create the RNG itself. I don't think that's going to be a big deal. So what I'm going to do next is look at how we do stuff with the ROM. So I'm going to open up the ROM file here. So I might have to blow this up too. Yeah, this is the font size is a little too small for this one too. Let's see. I'll bump up the size. Boom, boom, boom. Is that good enough? I'll do it one more time, just to match the other one. So here we call ROM new. So we're creating a new ROM. Here I have a hard-coded path. That's actually pretty bad. So that's something that we need to get from the config. Yeah. Well, actually, the config is going to save a file. We're going to open that file. So this path probably is going to be constant anyway. It's not something that the user has to configure. It's something that we're going to be loading after we save the file that they've uploaded and validated it and everything. So this is probably okay. If I decide to name it something like this. I might choose my own name, for example, instead. And then after that, we shuffle the ID. So this is part of the randomizer logic. We don't really care about that. And then we create ROM. We create the randomized ROM here using the shuffled IDs and the door data maps. Okay, so that's like the core information that we're going to need here. Is there anything else that we might want? Yeah, this is creating the game world. Okay, I don't think there's anything else. So it's mostly just this. Create randomized ROM in the ROM impl here. Yeah, so this is just something that this is a struct that wraps a buffer. So I think what we want is some kind of trait that lets us write. Well, we don't really care about these details, right? Like how we write bytes and stuff like that. That's not super important. I think what we really just want is this create randomized ROM method to be, because this is our business logic, right? This is our primary business logic. We want this to be abstracted out. So this will probably be part of our trait, and the implementation will look something like this, right? And that's probably good enough. That's probably plenty good. Because then if we want to mock out the randomized ROM, we can just pass in... Yeah, we can pass in like this vector string ID pairs and data door data maps. We'll get a result unit. Yeah, so this is just writing to a file. This is just mostly I/O. Yeah, this makes sense. This makes a lot of sense. Yeah, these are mostly just private helpers. Like, these don't need to be publicly exposed to our business logic at all. So this is actually completely fine. Only this needs to be in a trait. So that's, I think this is what we're gonna do then. What is door data maps, though? That's from the JSON module. Let's go open that up. So I think, if I'm not mistaken, that's probably going to just be some kind of... Oh no, it's a struct. Okay. So this is just plain old data. Door data maps. Just a hash map. String IDs. And... address. So address is just a usize. Destination. It's an array of 4 bytes. Okay. Yeah, we can work with that. I think we can definitely work with that. And I'm okay with these structs being the way that they are. We don't need to like abstract these things out. We can create these things ourselves very easily. So if we ever have to like mock these structs at all, it's very simple. I guess same with the ROM. The ROM itself is pretty easy to mock. It's just a vector of U8s, right? Like there really isn't anything special about the actual ROM. Yeah. So I think this is a pretty good start. Let's go with that. So where am I? Do I have the ROM? No, I don't. Okay. In that case, we'll just do this. Open it up. I'm in the wrong directory. I'm in the wrong project entirely. Yeah, because I'm still in the prototype. ROM writer. Okay. And this should be pretty simple. I'm just gonna call this method write randomized ROM. It's going to return an anyhow, oops, anyhow result, if I'm not mistaken. Returns unit. Okay, that's pretty good. I'm looking at the wrong file, as I tend to do. Yeah, and that'll correspond to create randomized ROM. And the interface looks very simple. Oh, actually, because this is an interface, I need to get rid of this. Right. Put that as a semicolon. Wait, do I need to mutate self? I think so, yeah, because this is constructed with the ROM. We have the shuffled IDs. Yeah, so we're basically going to go with something very similar to the prototype that I created, and then we're going to improve on it later. I think that just makes sense, right? Get something working end to end first, and then we'll start improving on that later. So obviously we haven't defined door data maps just yet. We will soon. Don't worry about that. But for now, I think this is a good interface. Ideally, I'd like to have everything compiling. So yeah, door data maps should be part of the config module. I'm going to probably work on that next. I think that's pretty good. Since this is a trait with only one method, I could do something a bit different here. Like, I could just use a closure instead. I could just write a function that takes a closure. That's another option. But this is complicated enough that I think that I'll just leave it as a trait. It's not necessarily a bad design, but there are different ways this could have been done. Yeah, so we're gonna leave this as is for now. Do I want to actually implement this yet? Probably not. We're gonna leave this. We want to just lay out the traits, get the traits going, get the modules up, that sort of thing. Speaking of, I actually don't know where I've defined the modules. Here I have. Mod error mod JSON mod ROM. I think this is using the new system because I don't think I have a mod.rs. I'm pretty sure I didn't have a mod.rs. So this is the new system that doesn't use mod.rs files. Yeah, that just means a little bit less typing, a few less files. It's nothing special. This is the wrong main. You know what? I'm getting annoyed by this. Let's just kill Vim. Let's just go to our project. I forgot what it's called. There you go, and we'll Vim from here. This is a good directory to Vim from. I wonder if there's a way to root your project when you're in Vim like that. Like I don't really know if there's a way to do that. There probably is. But like every time I try to open up netrw, it always starts from the other project. So, yeah. Could have googled that. Didn't think about it. Oh well. What are all of our modules? ROM writer. Oh wait, I don't have that open. Need to do this first. Yeah, so that'll be fine. We've got randomizer, we have main, we have graph, config, yeah, algorithm, config, graph, randomizer, VD. Randomizer, graph, algorithm, config. There we go. So we've now declared all of our modules up front. And I think that's it. I think we're pretty good with that. Does that trait need to be public? Probably. Okay. Now let's go back to ROM writer. Let's make this a pub trait. Now, when you make a trait public, automatically every method inside of the trait will be public as well. You can't, as far as I know, you can't have private methods within a trait in Rust. I know some people have complained about this. I think I have at one point too, although nowadays I'm like fairly certain I don't need that for most cases. But, you know, there's something to be aware of if you haven't written Rust before. Whenever you make a trait public, everything in it is going to be public. That's just how traits are defined. So next I want to create... oh wait, no, I've already created all the files, right? Because these are the different modules. We're gonna create our config module, I think. So this will correspond mostly to the JSON stuff, but it's also going to correspond to something that gets the options from Rocket. So you're probably wondering, how am I going to do that? How am I going to? I mean, I'm wondering at least. How am I going to do that? How am I going to get the options from Rocket? And I think, yeah, we have that example of multi-part forms. Right? They have a multi-part forms example. Why is this so small? Multi-part forms. Forms, there we go. So here... yeah, you can define your... structs as well, you can derive from form for your structs here, and that lets you get other fields like the name and password and stuff. I think that's probably what I'm going to be doing. Yeah, nothing else to it. I think should be fairly simple. So we'll be reading everything into some kind of like configuration struct, I think, or a bunch of different structs. And those will be passed to the config module. The config module will parse them into some big config that will be passing around the application. And yeah, that should suffice. Because this is also, not only will we be loading in this stuff in the config module, we'll also be loading our JSON file there as well. That's currently something that we're doing in main in this prototype here, but I think that belongs more in the config module. Because yeah, it's actually part of the JSON module that I created here. But yeah, I kind of want something a little bit more generalized than just a JSON module. I think this is the config module really. Yeah, we even had some unit tests here for making sure this thing worked properly, so that's good. We're probably gonna be copying those tests over as well. Yeah, I think this is pretty good. So I'm going to create a config module. How do we interact with this from main? Open doors file. Oh yeah. And this gets us JSON data. And what do we do with the JSON data? Get a game world ID map, door data maps. We pass game world into build game. Use ID map here, door data maps. Yeah, I think there is quite a lot happening here that probably shouldn't be happening here. Door data maps gets passed to this. Okay. But really, what this is just some big config struct, right? Like this gets the game world, this gets the ID map, this gets the door data maps. But this could be part of like some bigger config struct that also has other options that we could pass around. So really, we could replace this entire thing with, yeah, the config module. JSON data we might want to keep, but probably not, actually. Probably not. Because we don't really care that this is JSON or that it ever came from JSON. We're just opening this stuff, we're just storing these things in like our config struct, and we'll be passing that around. So yeah, that seems like a pretty decent idea. I wonder if there are any libraries that would be good for this, for like reading config. I don't know, I'll think about that later, like doing some kind of like validation logic. Because Rocket seems to have its own strategy for that, but I'm not sure how flexible that is. Applicative functors, you know, they're pretty good for writing composable config reading logic, or config parsing logic, so. I know Rust doesn't have applicative functors, but I think there are libraries that kind of mimic what they do out there. And I'm definitely tempted to give that a try if that's an option. But anyway, that's enough messing around. Let's start by defining our config trait. I mean, really, it's going to be a config struct that we get out of this. But, But I think the types that we get out of our config trait method here are probably going to be all related to, or they're all going to be custom types that I define, not stuff that comes from Rocket, for example. So it'll be easier to like mock a config if we wanted to. So we'll just create like a stub. Oops. So yeah, we'll have this config struct. We're gonna have this load config trait. So I think config will implement this, or maybe not. Maybe not. Yeah, maybe not. This is going to create a config, if anything. Well, we could just make this like a static function. I mean, I want to test that actually. So this is not going to take self or anything like that. If I'm not mistaken, there should be a way to actually call this. Let me go back to the ROM writer. We'll just comment this out for now, because this won't compile. Speaking of not compiling, I'll just throw that in there for now, because we're gonna need that later. I want to open a terminal. Yeah, this should compile and run. This is probably gonna take a little bit to build, actually, now that I think about it. Did I push? I think I did. but I can't remember if I did. Yeah, it's on main now. I have 2 branches still. I probably should get rid of this one. Let's delete this master branch so I don't get confused. I think maybe here. Branches, master. Let's delete this one. Main, that's the default branch, that's good. Alright, so we now have only one branch. Perfect. Yeah. I mean, like, while you're waiting for builds, because, you know, Rust projects tend to take a while to build, usually because of dependencies, right? And, well, actually, they usually take longest to build the first time that you're building stuff, and then incremental compilation usually tends to kick in after that and make things a bit faster, but sometimes things are still too slow, but, you know, in general, Rust does compile a lot slower than, say, Go, for example. So you definitely want to try and use your time wisely when you're waiting for builds, which I'm not currently doing right now. Let me think about this. So what I was thinking is we could actually do something like, I don't know, let config be a config, or I guess it'd be something like this. And I want to say you're able to do this? And that's like a static trait function that you can call. Like there's this syntax. I want to say you can do that. I'll have to see though. I'm actually not sure. It's been a little while. But I think that should allow me to create a new config. Yeah. We will see. We will see. Yeah, this does use the concrete config type and calls load config for that concrete config type. But of course this wouldn't work unless I actually implemented load config for the config type. So I will have to do that. But I think that does work. I think that is possible. Just not exactly sure. Let's see. Yeah. This loads a config struct. This could just return self if we wanted to create our own config. We will be passing stuff into this. Like, this won't be empty. This will be, we will be passing the actual configuration we load through Rocket from the multi-part form data into here, as well as the JSON file, actually. Which might just be a JSON path, come to think of it. Or that could just be an implementation detail, you know? Like, that doesn't have to be something we pass in. That could be something that we... Ooh, that didn't compile? Why is that? Config is private. Ah, of course. Make this public. Config, not found in scope, right, because it wasn't public. Yeah, I think this will be fine. If I impl load config for config, that should work. We'll just create a config, like so. There we go. See if that works. Does not work. Ooh. Maybe it doesn't like that syntax. Not right. Main. Yeah, this is a thing about namespace types. You gotta make sure you actually Well, I could have just used config in the scope of the main function to avoid that. So, function or associate item not found in config. Okay, maybe that doesn't work. I thought I saw that as an option, but so I wonder if I'm not mistaken. Trait static method Rust. Oh, that was my iPad making a noise for some reason. Or maybe it's the, okay. So I always call the trait like some trait, double colon, some method. Okay. It's probably the angle brackets. This is what you get when you read like... Wait, is that right? You know what? There. Less confusion. No! I thought that would work. Really? Maybe I need to import load config as well. You think so? No. Perhaps you need to implement it. I did, though. But I did. That's weird. Did I not implement it? Did I not save it? Does this need to be public? Did I forget to make this public? There we go. That's what it was. So yeah, that's one way of doing this. So this lets us create the config. That's pretty cool. I like this. And we can actually mock configs if we want. We can create our own custom configs, and those can be well, we're going to be creating it from the rocket data. So unfortunately, we're probably not going to be able to avoid using some of the rocket types. Yeah. True. So yeah, mocking a config is probably not going to be that simple. Unless we make whatever we pass into load config also mockable, which, you know, that feels like it might be defeating the purpose of all this. I'll definitely have to think about that. But I think that's a pretty decent start for that at least. We do have the ROM writer one right here. Okay, good. Yeah, I want to actually uncomment this stuff out now so we can start building this out. String ID, where was that defined? It's probably in here, right? String ID, okay, there it is, I see it. String ID is just a public type string. That begs the question. Does that really belong in the config module? Or should that be somewhere else? String ID. We could have another module for that. We could have like a util. Maybe not util. Maybe util's not really right. I don't know. Types module. Common. Something like this. I don't know. That could work. Very tempted to do that. And here we could have our types like... yeah, these can only public, pub type, string, ID equals string. Yeah, we have a bunch of different type aliases here. Door data maps. It's just like a plain old struct that we pass around. You know what? This is probably fine. Interestingly, this is actually not a public type, this address type here. Oops, that's not a 4. Okay, that's mostly fine. We need... so I'm also... yeah, I also was using a buy map here. I'm not sure if I'm going to need that. Yeah, I'll have to think about that some more. But I was using that originally. I'm probably going to be using it again, just because. We do want standard collections hash map. So that's what we have here. And there we go. We've now defined door data maps. We'll probably define more types later, but I think for now this is fine. I think multiple modules were using this, so it's good to just keep this somewhere where everything can access it. So I'm just going to put a common module down for common data types that are used across multiple modules. What else? What else? What else? And of course that means we should update our diagram too. So these things will probably have an arrow pointing to our common module. Maybe this. Oh, hello. Oh no. Oh no. That was a mistake. Can you not do that? Okay, thank you. Okay, we're gonna put down a box. So common. Oops. So there shouldn't really be any functionality in common, is my plan here. Everything in common should basically just be utility types that we share between the Rocket API and the randomizer and stuff, and the other modules here. So like config loader is going to be pointing at common as well, probably. We'll flesh this out a little bit later when we actually know what we'll be talking to common. Yeah, I think I'm good with this. Save that again, just to be sure. Was it config or no? Let's do a cargo check. It should type check now. Why is it checking everything? It's weird. Maybe I should have done a cargo build. Anyway, let's move on. Oops, don't do that. Let's open another buffer here. And we're gonna bring out the graph. Yeah, let's bring out the graph. This one's gonna be interesting. I think it's gonna have quite a few methods. I do have... Oh wait, no, the graph stuff isn't here. Right, this is just the application part, right? Because I created the randomizer engine, and that was, yeah. You see this? How this calls like graph dot edge endpoints and stuff. Graph is a game graph. Game graph comes from rando engine, so we're gonna have to look at that. Right, I actually think I've already designed this trait before in the past, and I think it did work for the most part, so we're probably just going to be reusing that one again. Associated type not allowed here? What? There are no associated types. What did I do? From writer. From writer. Why does it think that I'm using an associated type? Oh, because there's this here. I don't think that that's supposed to be there. I think this is, yeah, that's the vector, and this is that. That would make more sense. Yeah, cargo build. 4 errors. Door data maps not found. Right, we need to use common. Door data maps. Oh wait, that should be like super common. Actually, no. I don't think we need to use super because it's all at the same level, but I might be wrong. I'm probably wrong. Crate. Common. Oh yeah, and crate common string ID. String ID. There we go. 1 error. No external crate anyhow. Ooh. Right. I haven't done that yet. Anyhow. Get in here. What version is anyhow? See, now I feel like I'm schmoovin'. 1041. 1041. Yeah, feels like it's been a while since I've really schmooved when programming. But I'm starting to feel it again. That's awesome. It's a good feeling. Because yeah, I don't always do a lot of programming at work every day. So sometimes I kind of get out of it and I don't do enough programming on my own time. Because I like to spend a lot of time reading, which is good. Because I feel like you actually get quite a lot out of reading. Like, understanding more theoretical things. Maybe not to the degree of understanding like homotopy type theory or whatever. Like that, maybe that's not so practical for engineering today. But like understanding how to write more type safe code and stuff like that, just it just moves you along that much more than just, you know, trying to learn things for yourself and just trying to practice. Like, if you're just practicing in, like, Python or whatever, like, you're never going to learn how to write type-safe code. Or if you do, it'll take you, like, forever to actually pick up on that and be like, oh man, I could have been writing code that helped me prevent, you know, compiler errors all along. Or, I mean, not prevent compiler errors, but, you know, write code that prevents errors at compile time. You know, you don't generally think about that kind of thing until you actually read about it. And yeah, reading about, like, all that stuff in the Rust book definitely helps. But I find it also, like not just reading the book, but understanding other concepts is very helpful. Because sometimes I see people writing very, like, unidiomatic code for Rust because they just don't understand how to use the features of the language, or, like, how to work around certain problems. That like, a lot of people will come from an object-oriented language, and then they'll try and do things the object-oriented way, and they'll start trying to treat, like, traits as interfaces and pass around interfaces without using, like, generics or whatever, and then they'll get caught up because of, you know, the difference between, like, universal and existential typing, and that sort of thing can really mess people up. And then they'll look for a solution for their to implement things exactly how they want to, but the idiomatic way wouldn't be to do it that way, but to use a different feature entirely. Like, sometimes people look for, like, overloads in the exact same way that you would do them in Java, and, you know, they don't think about using things like traits to do overloading. Whereas if you're in, like, Haskell, like, that's all you really have, so it comes naturally that that's what you do to achieve overloading. That is that sort of thing, right? It's like, maybe you do have the expressive power to do, or good example from earlier today is someone made a comment, or they made a post on Reddit, and they were talking about, like, oh, I want to, like, get the value of my trait object. How do I do that? And it wasn't a very well phrased question. Like, they obviously don't really understand type systems very well. And what they were actually looking for was a downcast, but really, you generally don't want to be doing too much downcasting. I mean, certainly there are some cases where downcasting is appropriate, but, you know, if you are writing a lot of code where you find yourself downcasting a lot, there might be better options, like using enum instead, and people don't really think about that because they're so used to writing, like, C# or whatever, and they don't have algebraic data types, so when those kinds of situations come up, all they do is downcast, and they don't realize that that's less type safe than if you were to use an enum. And maybe the enum isn't always the most appropriate option, but in a lot of scenarios you don't need to downcast. And downcasting also kind of breaks the type system too. So, like, if you've written a lot of Haskell, I guess, or even Rust, right? Like, you don't have to, or you aren't generally going to be doing a ton of downcasting, and, you know, that kind of thing isn't really gonna come up very often. You're gonna learn how to design programs and work around downcasting. You're not gonna be using a lot of those features at all when you're designing programs. So I think it's kind of interesting that people try to do these sorts of things, and it's always good to read the theory so you can avoid, you know, shoehorning your mentality into certain paradigms and reaching for the wrong solutions in other languages. But yeah, anyway, let's continue on here. I don't have that much time. I need to get Shmoov in here. Right, I think next we want to do graph. Yeah, let's do graph. So I actually have a repo for this. Let's go look at that. I'll open a new tab for this. Don't look at all my other awful projects. I still haven't updated this Nix test project yet. I really need to do that. Yeah, I have it ready. I just actually need to sit down and do that. There's a lot of things where I just kind of drag my feet on them, and I really need to stop doing that. Rando engine, here we go. So the Rando engine has everything. It has all the useful stuff. It has the graph here. So we actually have a trait for this already, and this is really good. I'm probably just going to copy this. I'm probably just going to copy this wholesale. I don't think we need anything different from this. I think this will be just fine. This gives us the edge count, the edge endpoints, edge indices. The ability to add an edge, remove an edge. Yeah. Check if the game is beatable, that sort of thing. Why is... That's weird. That should be a boolean. That should just be a boolean. Why is this a... That's weird. That's not the interface I would expect for that. Did I really just do a result unit error? Oh, because I wanted to... Oh, okay. I see. So, yeah, here's something interesting. I wanted to be able to return errors because... Yeah, I wanted to be able to give information on, like, why the game is unbeatable. And it never really, I didn't really have a good way of doing that. Interesting. Let me think about this a bit. Alright, so I condense the graph. Make it acyclic. And then we check this. Oh, I didn't use Kosteraj's algorithm or anything, after all. I think that's... Although I think that is called by condensation under the hood. So really, this is what we should be returning. Let me think about that. The condensed graph is created by calling condensation on our graph type. So that's an implementation detail. Ooh, okay. You know what? What we need is some kind of condensed graph function in our interface. Then we pass the condensed graph into game beatable. Then we check if it's beatable and return a boolean. I think that's a more intuitive interface, right? Like, because when I saw this, I was just like, what? Why is that the interface for this? And then if we fail to get a beatable game, then we can call yet another method that will handle that. So I think we might want to actually add another interface method here. There's a lot of interface methods, so I might want to break this out into its own interface for checking if the game, the graph is, or if the game is beatable. Like maybe this doesn't belong under the graph trait. Yeah, because we can have multiple traits. We can compose traits. That's easy. We can always implement more than one trait for a type. And then just have like a graph interface purely for the graph itself. For the graph operations. Like getting the edge endpoints and adding edges and all that stuff. That might make more sense. Yeah, let me think about that. Breaking it out into 2 different traits in the same module, even. That's an idea. That's definitely an idea. Are there any perceived benefits to doing that, though? I guess is the real question. What would be the benefits of doing that? Well, we would have less methods to implement if we're just trying to implement the graph trait for some graph type, right? So if we're making like a mock graph and we just want to test out certain things, like adding edges, removing edges, that sort of thing, that's a lot easier. We don't need to check if it's beatable and all that. So that's potentially worthwhile. But I think for now, probably isn't worth it. There are some funny things going on with this, that's for sure. Edge indices returns an edge indices unit. I wonder why that is. I don't know enough about the edge indices type. That's obviously part of pet graph. And we might want to actually wrap these in our own custom types so that we aren't using pet graphs types directly. That way it's easier to mock this stuff out and not have to use a pet graph specifically when we're testing. I think that would actually be a very good idea. So I'll create my own. But then if I'm wrapping it, no, that's not. Then that's not really helping. If I'm just putting a wrap around it, then in order to construct that, I still have to. Yeah. It could be a trait. Maybe I'm thinking too abstractly. Maybe we don't need to add so many abstraction layers here. Yeah, I have a lot of decisions I could make here. And here we have, yeah, this into weighted edge. This abstraction doesn't really help that much because we're still directly tied to pet graph is the main problem. Like, this trait doesn't really help us if it's going to be using the pet graph types. Because that means we're still tied to pet graph. Maybe that's okay. But the whole point of this was in case we wanted to swap out to a different graph library or graph implementation, right? We don't want to be forced to just use pet graph for everything. So I'll have to think about this. I might need to use a more abstract interface that doesn't look like this. Yeah, let me think about that. And then we'll rewrite this, I guess. Tough. That's really tough. I'm gonna call this game graph. Actually, no. I'll just call this one graph. Because it's called graph.rs already. Is that what I called it here? Yeah, I just call it graph. So that does match our interface. And then we'll have like a pub struct game graph implements this. And that shouldn't be a problem. That's rough. That's really rough. I suppose what we could do is still take an iterable here. And use our own custom edge type. Like if we just took like a vector of edges and then converted that into a pet graph, that could be fine. I need to rethink this interface here. This one doesn't make much sense. I definitely need to rethink this one. I'll come back to it. Shoot. Well, it's 6. We gotta hurry. We gotta schmove. We gotta move. Edge count, that's fine. Edge index, this is probably fine too, but I think I need to actually create like a custom type for that. In maybe common? I don't remember where I get edge index from. Let me double check. Edge index comes from pet graph. Okay, maybe not. Yeah, I think we need to have our own custom types here. So tell you what, edge indices, this can be I don't know, U32s, or maybe because an index, maybe U size, assuming that they also use size as well. It shouldn't matter because I should be defining my interface how I want to, right? Like that's what matters here. Yeah, node IDs can be I'm not sure. I'm really not sure. Edge indices. That's probably also going to be iterable, but yeah, I'm going to comment that out for now. Edge index, node IDs, that's fine. Edge index option, that's fine. Actually, is that fine? Yes, I think. Because if I'm removing an edge, it shouldn't return anything, right? Because we're just mutating the graph. But it will... It does mean that... Yeah, we might fail to remove the edge, basically, is what the option's for. I might change this interface entirely. The problem is this interface is directed by the implementation, and that's bad. I shouldn't have done that. I'm talking to YouTube. Hi, this is my sister. Oh. Yeah, I need to wrap up stream, so.
Yeah, it's dinner time.
All right. We're gonna leave this here. I'll try and finish this off camera, and yeah, I think we're on the right track here. I think I could have changed this interface so it doesn't do all this like mutation and stuff. I probably could have moved the graph actually. That might have been better. Actually, maybe not. Maybe that would have been slow. No, it's really hard to say. Yeah, passing things by reference is always gonna be, or not always, but generally it's gonna be faster. But kind of hard to say. I want this to be Boolean. I don't want this to be that thing. We're gonna add a couple more methods, like condense. Yeah, that's fine. Or maybe it's. I actually don't know. I actually don't know what condense does. I think it returns a copy, but I don't remember. I don't actually know. And if the graph is deemed beatable, then we want to return an error. Game is beatable. Beatable. Oh, we already have game beatable. Validate? Or... I want to think about this a little bit more. Game beatable. Well, we know that the game is unbeatable in this case. So... Yeah, that's tough. That is tough. Maybe the result does make sense here. Either it's beatable or we return some errors. I think condensing the graph might need, or should probably be its own thing. I don't know, maybe we do just want to go with the original interface here. I don't know, the more I think about it, the more I kind of like this. Maybe this unit could be something different. It could just be like an empty struct called beatable that doesn't have anything. Just to indicate that yes, I acknowledge that if this succeeds, it is beatable. We'll go with that. Or error. Error obviously isn't defined. That's okay. I'll comment this out for now because I need to implement the error type somewhere. We'll make a struct beatable. This is empty. We'll use that kind of as like a marker to say that this thing is beatable. So it's either beatable or we get an error. And I think that's fine, because beatable is isomorphic to unit. Okay, well, I don't have any more time to stream today, so we're gonna have to leave it here. But yeah, that's it. We're going to finish this off tonight. Well, I'm gonna finish this off screen tonight, and then that should wrap up the sprint. So yeah, if you watched this after the fact, because I'm pretty sure there's no one viewing right now, then yeah, thanks for sticking around.